kind of keep the attackers at bay and keep them out of the cloud and on-premise networks. You really need a good strategy of defense in depth. Don't just rely on that one or two tools and think that they're going to be everything. A good attacker is going to do their homework on you first. They're going to do lots of enumeration to figure out what type of defenses you may have in place to see if there's bypasses or something they can develop to bypass. And so you kind of need to have a holistic view of, all right, given my situation of here's what I have on my on-premise network and here's what I have in my cloud network and here's how they all communicate, where are my largest areas of weakness? And now that I know where my largest areas of weakness are, how can I put something to kind of detect if someone's aiming for that weakness or if someone's aiming for that vulnerable soft area in either the cloud network or the on-premise network? And so kind of have some defense in depth so that even if we bypass antivirus, there's plenty of artifacts that we leave behind as attackers that still allow you to find us and hopefully stop us, or find the real attacker and stop the real attacker before they actually do ransomware or whatever it is they're trying to accomplish. A Raspberry Pi is just a little mini computer, kind of about the size of a deck of cards. You can actually buy them in different form factors, so you can buy slightly bigger ones, you can buy smaller ones also. And the good thing about them is that they're essentially a little mini computer, little mini Linux computer that allows us to use them in lots and lots of different ways. So one common thing for attackers is if they break into a building, to leave something behind so they can continue to access the network even after they've left, or even if they've detonated a malicious payload, they can still leave behind a physical implant. This is something that is also used by advanced adversaries and nation states. They will actually have more advanced physical implants that can be plugged into different areas and do different types of attacks. And we try to simulate that with our own RedTeam engagements. So in this case, a Raspberry Pi is a rather cheap device. It only costs about $30 to $35. And it's actually just this small little board, and you can get cases for it, or you can conceal it in different devices. So you could conceal it inside of a bag, or I've seen them concealed inside of Cisco phones, so it looks just like the rest of the phones that a company may use inside. But what they don't realize is that there is a mini computer that, if it can get onto the wireless or if it can get onto the wired network, can then do a number of different attack techniques that can help us out to try to achieve our goals. And it's one of the greatest things about it is its flexibility. So the ones that we use, it can either just call back to our cloud servers and we can control it, or oftentimes we can make it so that the traffic that it generates looks exactly like real web traffic. So if you're looking for malicious traffic, you may not notice it right away because it looks just like a regular web traffic, and then it calls back to us with that regular web traffic, and we can control it that way. So it's a really nice, flexible device that if we get into a physical place, we can hide it in different areas or conceal it in other devices and put it on the network in hopes that we can do lots of different types of attacks, and that would be our entry point into the network. So besides Raspberry Pis and Arduinos, there's actually a whole suite of different tools that anybody can go online and buy. There's a very good pen testing company called Hack5 that sells a whole set of gear, such as a plunder bug or a packet squirrel or a land turtle. And these are collections of different types of physical implants that can be plugged into a network to achieve different goals. And there's even a cloud service that they sell for remote command and control. So even a low-skilled attacker or a pen tester can then come in and plug in one of these devices and take over a network. So at RedTeam Security, we develop different types of scripts and little tools to help us with our job. It can be something as simple as just writing a bunch of automation to help do something that would manually take a long time, or it can be a whole coding project to make sure that we can evade antivirus, so that we can actively emulate what the real bad guys are doing. So when you hire us, you actually are getting a accurate representation of what's really going on in the wild at this moment. So we will help develop these techniques and then share with our clients, all right, how do you stop this? How do you mitigate this? What are ways that even if one detection is bypassed, what are the other ways that we can still find you and stop you? And that's what we help them discover and put on their network. In addition, a lot of these coding things, you don't need a degree in computer science. It's more just an understanding of systems, how they talk to you, how your computer on your desk talks out to the cloud and actually communicates up there what's really going on, and then just figuring out, all right, how can I make something to intercept that communication, replay that communication, attack that communication, and just getting in the mindset of, all right, what would be interesting to a bad guy, or how could I abuse an application that's already on this laptop to do something that a bad guy would also want to do. So there's certain cases where we need to make a special tool to do something that doesn't exist yet that we know that can happen, or there's other cases where we can just reuse existing tools to do malicious things.